In the Thar Desert in India, these engineers are building a technological marvel, a continuously heated and insulated pipeline to transport the crude that is waxy. It's a remarkable 700 kilometers long, and it stands at the pinnacle of pipeline engineering. The Mangala development pipeline owes its success to a unique technology that keeps the pipes heated over an astonishing 65 degrees centigrade, 24 hours a day and 365 days in a year. Bit by bit, we will uncover the story behind this technological marvel and reveal how the engineers built the world's longest, continuously heated and insulated pipeline in the extreme weather conditions of the Thar Desert.
It looked like it's a very, very difficult project because it has never been done in the world for 600 to 700 kilometers.
What we have created is engineering history.
The Barmer district of Rajasthan in India is a place where daytime temperatures can rise as high as 50 degrees centigrade. By midday, almost all life around the desert retires to cool and shady places, except for the pipeline crew. Every day, more than 5,000 workers brave the extreme heat to complete the mammoth engineering project. Their mission is to construct a pipeline that will overcome the challenge to the biggest onshore oil discovery in India in more than 2 decades. The journey begins in 2004. An oil exploration company called Cairn India makes a huge discovery of crude in the northwestern state of Rajasthan. They name it Mangala, or the auspicious one. One after another, 25 new discoveries are made in the same field. More than 4 billion barrels of crude are discovered 1.5 kilometers under the earth, out of which more than 1 billion barrels are recoverable. This is the biggest onshore discovery in India in the last 25 years. That's the good news. The downside is that the crude is waxy. That means that no sooner is the crude retrieved and brought to the surface, it solidifies. It becomes as hard as wax. To get the waxy crude to flow, it needs to be heated to a temperature above 65 degrees centigrade. The big challenge here is to make the crude flow so that it can be transported all the way to the refineries. In the absence of a market, the oil exploration and production company will be forced to postpone the production of crude or, in extreme conditions, even abandon the field.
It's not a small problem. If the oil won't flow on its own, how will you produce it? How will you transport it? The only way to do is to heat the oil up and keep it in a heated condition while producing it, while storing it, while transporting it, and while delivering it to the customer.
Heating thousands of barrels of crude requires huge amounts of energy and water. Fortunately, the production company has already found a vast reserve of natural gas, which can be used to heat the crude. But finding water in this desert is almost impossible. Even so, determined to tap this very large resource of crude, the production company launches another big exploration campaign, this time for water. The exploration team uses the same high-end technology to look into the inner depths of the Earth. only 20 kilometers away from the oil fields, they discover a huge reserve of underground saline water.
Right from the beginning, we were very conscious that we are operating in a desert region and fresh water is a precious commodity for the local community. We were deeply committed that we should do nothing that would harm the community's resource. And therefore, we brought into play the best of our technology that we used for discovering oil, for searching for water, and that's the way we discovered the saline reservoir.
The discovery of oil, gas and water in the same block, as it were, solves the problem of extracting the crude. The production company will use the energy from the natural gas to heat the waxy crude. They will pump in almost an equal amount of hot water inside the earth to extract the crude. A major portion of the extraction process is thus solved. What remains unsolved is how the crude is going to get to the markets and refineries that are several hundred kilometers away.
When we discovered the crude oil, we realized the quality of this crude is such that it required a unique technology to transport this crude oil. And when we looked for options, we also realized that the government nominees were reluctant to invest in this technology and build this pipeline. It is then, in conjunction with the government, we decided we will build this pipeline as this is one of the fastest and the best way to produce the crude oil and transport it to the market.
The engineers are working hard to find the best design. This pipeline cannot be an ordinary steel pipeline. The new pipeline should be able to keep the oil flowing. If it cannot do that, then the crude oil will solidify inside the pipes and clog them. There are other challenges. One of these is the route this pipeline will have to take. Generally speaking, this route must be the shortest available to get the crude to its potential buyers. However, the shortest possible route runs through the Gulf of Kutch in Gujarat. The Gulf of Kutch is a fragile ecosystem and is home to several marine and avian species. Even though it added 75 kilometers to an already ambitious pipeline, the engineers extended the route in order to conserve the environment.
The environmental issues are quite significant on a project of this scale. But we have a specified route which we've studied long before we put anyone on the ground to do any work. And that route takes into consideration environmental sensitive areas. We have to do an environmental impact study and a social impact study. So we have to be mindful of communities, water sources, cultural relics or religious temples or any other religious site. So that's all taken into consideration when we select the route.
The final route will now cross hundreds of man-made and natural crossings like canals, rivers and railways.
The pipeline would enter Gujarat state from this area, which is near the village of Dua, and then travel southward.
It is January 2007. The engineers have sorted out all the major issues relating to the sale of the crude, preservation of the environment, and the feasibility of the technology. The only remaining challenge is how to keep the waxy crude in a flowing liquid state.
If we were to pump the Rajasthan crude into a regular steel pipeline without insulation and without any heating system, very quickly the crude would cool down. And as it cooled down, it would become harder and harder to pump. And actually, within 200 or 300 kilometers, it would start to solidify, and you couldn't pump it at all.
The answer emerged in a technology known as Skin Effect Heat Management System, or SEMS. This nearly 700-kilometer long pipeline will be laid 1 meter under the ground. 2 sets of pipes will be laid next to each other. The bigger 24-inch pipe will carry the crude oil, and the smaller 8-inch pipe will carry the natural gas produced in the Rajasthan fields. The larger pipe is wrapped in 3 different layers, of which one layer is insulation. These coatings minimize the heat loss. They also protect the pipeline from physical damage and corrosion. The smaller 8-inch pipe will supply natural gas to the gas generators of 1 megawatt each. These generators will pass an electric current of 4,000 volts through a 1-inch carbon steel tube. An electrical SEMS cable is placed within this 1-inch carbon steel tube. This entire system is welded to the main pipe carrying the crude oil. An electric current will run through the cable and then flow back through the inner walls of the 1-inch steel tube. Resistance to the flow of electrons in the 1-inch steel tube results in the generation of heat and causes the temperature in the steel tube to rise to as much as 90 degrees centigrade. This heat then gets transferred to the main carrier pipe through conduction, where the hot oil is already flowing in the pipeline.
In some ways, the SEMS system is the lifeline of the pipeline. In the event that the flow slows down or stops, perhaps in an upset or for operational reasons, the risk is that the pipeline could turn solid and then you would be unable to pump it. But with the heating system, you always have the ability to heat the pipe up and to remelt the crude and to keep it flowing.
We conducted a field trial test of over 1 kilometer of line, and we later on came to know that the results are exactly and even better than the design.
The company is now ready to construct the world's longest continuously heated and insulated pipeline. A company that was never in the pipeline construction business to begin with is now about to create history in pipeline engineering. The project's team members are informing nearly 50,000 farmers and landowners through whose land the pipeline will soon have to pass through.
Our company believes that one of the most important license or approval to be obtained is from the community. And to achieve this, we are approaching about 50,000 landowners across the pipeline route. We are telling them about how important this project is for the country and for community. We are also informing them about how we'll construct the pipeline through their lands and how we'll make sure that there is minimal impact to the lands, and once the project is over, the lands will be returned back to them in near to original condition.
Meanwhile, in Mundra, massive sheets of steel are being rolled into pipes and welded. Each pipe is going through several quality tests, including X-rays and ultrasonic rays. These pipes will then be carefully transported to several different locations throughout the length of the project. Each stage of laying the pipeline is carefully planned and executed. First, the notified areas are marked and cleared of all vegetation. Although the required trench is only 2 meters wide, a 30-meter strip of land is graded and leveled to facilitate laying of the pipeline and other construction activity. Topsoil, a precious resource, cannot be wasted or thrown away. The team ensures that it is kept safely so that it can be returned once the pipeline is buried under the ground. The team takes care that farmers get back their land in as near original condition. A 2-meter deep trench is then dug and the ground is prepared. A project of this scale and size requires immense discipline, planning and foresight. More than anything else, it requires the safety and welfare of its workers and people living nearby.
At the end of the day, it's all about people. And people should go home from work just as well as when they arrived at work, so that they are not suffering any harm from the activities that we conduct during the course of our business.
The pipes are now laid end to end and welded. The winter months are over. It is again summer and temperatures are soaring. Stringing and welding are time and labor intensive, and in temperatures above 50 degrees centigrade, the job gets tougher. Ambient heat combined with the heat generated by welding can weaken the resolve and efficiency of the best in the workforce. Meanwhile, 100 kilometers away at the Luni River crossing, it's not the heat that's bothering the crew, but underground water that has seeped through and formed an unwanted pond. Moisture is the enemy of any pipeline. Sukhri and Luni are among several seasonal rivers that the pipeline has to cross. There's a likelihood of their flooding if the monsoon rains are unusually heavy. This could damage the pipeline. So here, the pipeline is laid 10 meters underground with an additional concrete coating.
There's no water in the river course, but it could be today, it could be tomorrow, and it may never be in this monsoon, but we can't take that chance. So we have to calculate at what the scour level, what was the historical data of the deepest scour level, and then we lay the pipeline 2 meters below that deepest scour level.
A few kilometers downstream, the team at the canal crossing is tackling another engineering challenge. This canal is a lifeline for thousands of needy farmers living downstream, and the engineers cannot risk any damage to it. 700 such difficult crossings are negotiated, using state-of-the-art technologies like micro-tunneling to cut through rock and lay the pipes. Back at the main location, the pipes are welded, tested, and approved. After stringing a considerable length, 4 heavyweight booms gently lower the main 24-inch pipe next to the 8-inch pipe that will carry the gas. A layer of soft soil is added till the trench is leveled. A warning tape and optical fiber cables are laid over the pipes. AGIs, or above-ground installations, are commissioned to supply electricity to the SEM system throughout the duration of the project. The AGIs are built every 18 kilometers along the pipe's entire route. The land is now ready to be returned to its rightful owners, the farmers. Hariram has once again sown wheat. In a few months, when he harvests his crop, thousands of barrels of oil will flow under his fields.
मेरे खेत में से जो तेल की पाइपलाइन गई है, उसको मेरे को पैसे मिले. उस पैसों से मैंने एक तो इंजन लाया हूँ और एक फुवारों का सेट, और बाकी मैंने अभी फसल में कम पैसे लगाए हैं. और हमारे यहाँ पे पानी की कमी की वजह से 2 इंजन लगा के उससे और डीजल जला के फसल चलाते.
Back at the Mangala oil field, the pipeline undergoes a series of final tests to make sure that the entire 700 kilometers of pipe is fully secure. The pipeline is pressurized with water to ensure there are no leaks. Once the water is drained, the pipeline is purged with nitrogen to prevent internal corrosion. The preparation work is done. Now, one by one, pipeline inspection gauges are being sent through the pipeline as a final process before commissioning. The pig train carries a selection of chemicals to clean the pipeline of moisture and other contaminants. These agents will also guard against the buildup of rust. With the insertion of the fourth and final pig, oil is pumped into the pipeline. A courageous vision has now set a new benchmark in the world of engineering. Cairn's dream of taking the viscous crude to the market is now a reality. This pipeline is the longest pipeline in the world that is electrically heated and insulated all along its entire length of 700 kilometers. It is the only pipeline that has a complex network of 36 AGIs to provide electricity to its heating system throughout its lifetime. For Cairn and its partners, this is a most valuable endeavour. This pipeline allows access to 75% of the country's network of refineries and helps improve India's energy security.